8.2, part 2, we are using trigonometry and Pythagorean theorem to find lengths of right triangles. So we can't always use Pythagorean theorem, so we're going to use the trig facts that we've learned previously to help us find segment lengths of right triangles. So just a reminder, SOHCAHTOA, what that stands for is sine means we're talking about the opposite side over the hypotenuse. And remember, trig functions are just ratios of side lengths. So the sine of a certain angle is always going to be the same proportion in every right triangle that has that same angle.
Mr. Shannon, so extension 46011.
Similarly, cosine of that angle, and this is a theta symbol, that's what we use to represent angles, is going to be the adjacent side over the hypotenuse, and tan of a theta, any angle, is always going to be the opposite side over the adjacent. So if you look at this picture, we want to figure out how long BC is, so I'm going to call that x. We can't use Pythagorean theorem because we don't know anything about the hypotenuse yet. So we're going to use trigonometry. And I know that we're going to use this angle, angle B, because we know it's 15 degrees. And if we look opposite, that's the side of 10.2. And then x is right next to angle B. It's touching it, and it's not the hypotenuse because the hypotenuse is across from 90 degrees. So we have an opposite side and we have an adjacent side. Now, which of these three trig functions talk about opposite and adjacent? Well, tan does. So we're going to use this equation, and we're just going to fill in our knowns. So tan of the angle, we know the angle is 15. So tan of 15 equals the opposite side, which is 10.2, over the adjacent side, which is x. And then the shortcut for this, and I'll explain it why in class, but you can trust me that if x is on the bottom, all you have to do is flip-flop these two things. So really, x is going to equal 10.2 over tan 15. And some of you guys, this tan 15 is going to freak you out, but it's just a number, and if you pop it into your calculator knows what number it is. So all you do is plug this into your calculator. I'll show you how to do it tomorrow in class, but you should get to 38.07. If you know where the tan button is on your calculator, try it. If you don't get 38.07, then again, we'll work on it in class. Okay. So now moving on, the second question says to find AB of the same triangle. Well, we already know that this side is 38.07, but we rounded a little bit. We could use Pythagorean theorem. You could say a squared plus b squared equals c squared, but it's not going to be as accurate because we rounded here. But that's fine. If you want to use Pythagorean theorem, you're more than welcome to use Pythagorean theorem. So we would do 10.2 squared plus 38.07 squared equals c squared, and then figure out how long c is. So 10.2 squared plus 38.07, and then square root, and I got 39. C equals about 39.4. If you wanted to, you could use trigonometry. If you didn't want to use Pythagorean theorem, you could use trigonometry. And what you would do is we want to figure out, always use the information they gave us. So they gave us the 10.2, they gave us the 15 degrees, and we want to know what side this is. So this is the hypotenuse. Your setup would have been, well, since they gave us the opposite side and the hypotenuse, we're going to use sine because they talk about the opposite and the hypotenuse. So you could have set it up as sine 15 equals 10.2, the opposite, over the hypotenuse, which we'll call c, and then solve. Again, just like what we did before, since the variable is on the bottom, all you do is flip-flop, and you get that c would be 10.2 divided by sine 15. And you should get the same answer, 39.4. Okay, one more example. I'm going to do trig for both of these so you can get used to what it looks like. So we want to figure out what QR is. I'll call that x. They give us the 63 degrees, and they give us 12.9. So let's talk about what these are. Well, in respect to the 63, x is across, so we're going to call this the opposite side. And 12.9, it looks like it's adjacent. It is adjacent, but it's across from the 90 degrees. So this is actually the hypotenuse. So which trig function, the next thing you do is think which trig function talks about opposite and hypotenuse, not cosine, not tangent, sine. So we're going to use sine of the angle equals opposite over hypotenuse, because again, this is just saying that when you look at the ratio of the opposite and the hypotenuse for this angle for 63 degrees, it's always going to be the same thing. So we're filling our knowns. Sine of 63 equals opposite, which we don't know, over the hypotenuse, which is 12.9. This time x is on the top. So what's the opposite of dividing by 12.9? It's multiplying. So really our answer is 12.9 times sine 63. And I want you to put this number in front of sine 63, and that'll help you put it into your calculator easier. So put the 12.9 in first, times sine 63. And I got that x should equal 11.5 centimeters. Okay, so QR is 11.5. Moving on, I'm going to erase some of this stuff. We're going to use trig again. You could use Pythagorean theorem now that you know what a second side is, but I'm going to use trig instead. We want to figure out what QP is. So I'm going to say that QP is y. Again, look at all the stuff that they give you. They give you 63 degrees, they give you 12.9, and they give you the y. So we've already said that this 12.9 is across from the 90 degrees, so that's our h. And the 63 is not opposite. I'm sorry, the y is not opposite of the 63. It's touching the 63, so that would be the adjacent. So which trig function talks about adjacent and hypotenuse? That's cosine. So our setup this time is going to be cosine the angle equals adjacent over hypotenuse. And then you plug in your nose. Cosine of the angle 63 degrees equals the side adjacent, which we don't know, over the hypotenuse, 12.9. So this is the same kind of setup as last time. The opposite of dividing is multiplying. So you'd say y equals 12.9 times cosine 63. Now, some of you guys are gonna be like, this is the same thing that we did last time. Nope. Last time we had sine 63. This time we have cosine 63. It's gonna be a different number in your calculator, because when I pop it in now, I get that y will equal 5.9. Okay, again, if you have a cosine and a sine button on your calculator, try it. If you're not getting the same answers, then we need to talk about that in class. Okay, so your homework for tonight is to try to do 5 and 6 and 7 and 8. And I will check that in class. Right, so again, today we used trigonometry and Pythagorean theorem to find lengths of right triangles. Done.